Welcome to Private AI Lab, the podcast where we experiment, explore, and debate the future of AI behind the firewall. I'm your host, Johan, and every month I have a guest in the lab to break down real-world use cases, challenges, and innovations shaping private AI. In this episode, Robbie Jerrom will join me to talk us through the Red Hat AI portfolio, his experience with the DGX Spark, and how it fits into the OpenShift AI platform. So, enjoy the episode. So, we're at the first experiment, and in the first experiment, I'd like to know Robbie a lot more. I know him, I think, pretty well, but I can imagine that you guys maybe don't know him yet. So, Robbie, could you, first of all, welcome to the show, and second, could you briefly introduce yourself and, explain what you do at a day-to-day basis?
Yeah, sure. Thank you for having me on, Johan. It's great to see you again. I'm Robbie Jerrom. I'm a principal technologist at Red Hat for all things AI. So on a day-to-day basis, I get to experiment with models, run things in inference, use a lot of big GPUs, and run up some great builds. But my most favorite thing to do is to do that stuff in data center where I don't have to worry about the bills and things too much. So I spend about half my time working with open source projects and pulling those projects into obviously the Red Hat solutions. And the other half of my time, working with communities and customers around what they can do with AI, particularly generative AI. So that's me. I think I've got the best job in the world.
Awesome. I like people that love their job because, and I can tell, like, if you're listening to the podcast, I really invite you to look at the either the Spotify video or the YouTube video, because if you see Robbie talk about his job, his eyes start to sparkle. So you're not lying here, my friend.
Absolutely not.
No. So there's always I mention always, but this is the third episode, and there's kind of a thing I always like to ask during the introduction, and that's kind of the question you don't really expect. And I got a series of them, but yeah, there's one that's my personal favorite. So, what's the first or funniest AI fail you've ever seen?
Funniest AI fail. I think the funniest one was a few years ago when we were all excited about self-driving cars, and I was out in Palo Alto, and I was having one of the I think it was a Tesla Model 3 demonstrated to me, and they're like, it drives itself, and it did drive itself. It drove itself straight out of the car lot, over a dirt path, dirt bump, and then got stuck. And this was my first demonstration of the new self-driving capabilities, and I was just kind of stared at it for a little bit and thought that's not what it's supposed to do. Um, and It was a complete fake. The guy that was showing it to me intentionally drove it to fake me out. Um,
Really?
yeah. So then he reversed it up and showed me the AI driving the car around the car park, which was actually very impressive. But I was completely convinced that AI wasn't a thing and this Tesla was just rubbish. Um, so that's the one that brings to mind when you say, yeah, AI fails. It was a complete fake out. It was a successful demonstration of AI, but I did enjoy it, and I remember thinking, oh, are we there yet with AI? Well, maybe we're not. And then it was like, okay, big reveal afterwards. It worked really well. So that's my favorite one. I think my most
So,
expensive one was an accidental provision of some significant GPUs in a cloud, where I instead of One, I put a few extra zeros on the provision of GPUs, and I ended up with 10 instances with 12 GPUs per instance, I think it was. And I've never hit shutdown faster. Um, so that's the one I remember most from a possibly career impacting. I mean, to be fair, the cloud provisioned up all of the GPUs, all of the nodes perfectly. And I spent the whole time while it was provisioning wishing the cancel button was ready to be clicked. So yeah, that's yeah, AI could be expensive.
So what were you trying to spin up? Do you still know?
I was spinning up just a Kubernetes cluster with a bunch of it was A100s at the time. So I think I could provision eight A100s
Ah,
per server. And instead of provisioning up just one because I was just going to do some tuning, I provisioned up 100. And it took a long time to spin up 100 nodes, each one with eight A100s in it. Um, and all the time I was mentally doing the maths on how much it costing per minute for these GPU resources, and until I could hit the deprovision button, because you can't deprovision until it's finished provisioning. And it
yeah.
it, it took about an hour, or maybe more, maybe more than that. And I was like, okay, so do the math, right? Eight GPUs per node, 100 nodes, and it's there for at least an hour before
Oh
I've done
man.
anything. So yeah, that's my biggest personal fail. Visioning resources incorrect.
Wow. So, also coming back to your first story around the Tesla. So, have you seen or heard the news? And I'm quite sure you have around one of the humanoids that was launched last week or the week before, where the whole world thought it was completely autonomous, but in fact it was remote controlled using a remote.
Oh wow,
Um,
I
yeah,
missed that.
and the story behind it was like, there, of course, there will be a ton of humanoids being developed now in the future, like 10 years from now. The vision would be that humanoids will probably be a more common thing in households. But there's the full autonomous humanoid that runs full AI, and there's the humanoid that's being remote controlled by people, people
Hmm.
at, I don't know, the other side of the pond, or in countries there, where um, lower wages are, or and being remote controlled from there. I was kind of amazed by hearing that, because I always thought that the whole idea of those robots being fully autonomous is that is kind of the future, but there's also a ton of cost going into there. Plus, and we've been playing around with a robot dog in the last couple of months. Um, Being able to fully autonomously run such a robot requires a ton of infrastructure, to be fairly honest. I mean, you need to run different types of models, not just the language models that we use to, to talk to it, or to listen to it, but also computer vision models that recognize all sorts of things. They can't simply live in a relatively cheap humanoid. So yeah, I don't know, something, definitely to keep your eye on, and also, um, kind of the balance, or the mixture between true autonomousness. I don't know how you call it, but also the fact that there's still an engineer or an operator behind those kinds of services. Um, I think they'll have a future as well.
Yeah, I think there's two. I mean, there's two parts to that. Right? I mean, the little robotic dog things. I mean, I saw you walking that around at an event, and I was kind of jealous. I thought that was really cool. But the training of those models, and as you say, it's not a single model on the robot, right? It's a whole bunch of different models working in concert to do things, and we're starting to get to the point where that's becoming feasible. But go back 3 years, and it was almost unthinkable to be able to have a reasonably inexpensive robot dog for you to play around with in the lab, where you could train models and do vision models and do stuff, right? So we're accelerating incredibly quickly, but a lot of that is around how you're training the models and our ability to spin that stuff up in a data center, to run synthetic data tests across all of them, train thousands of those models all at once to see which one performs the best, and then download that onto the robot. You know, we couldn't do that 6 years ago. There are industries that could, but it's almost to the point where you and I could do that over a weekend, and we could come up with something that's kind of cool. And that acceleration, and then when more home labbers and open source folk get involved, is where the technology moves forward much more quickly. And I think we're not there with the fully autonomous robots yet, but go back a couple of years and we didn't have an AI system you could chat to book your day off at work, and we can do that now. So it's gonna, the more we open it, the faster it's going to accelerate, and we've realized that now. We've got the likes of NVIDIA talking about the importance of open source. Your good selves, Red Hat, of course. We've always been doing open source, so that open source AI is just going to drive that path to fully autonomous just more quickly. I mean, I think we're a
Yeah.
good few years off iRobot yet, but we'll get there.
Yeah. No, I'm also quite sure that definitely is something that's on the horizon. It's a far horizon, but it is there. So you mentioned a couple of things already, like home labbing, open source, and I think that's a great segue into experiment number two, which I call the deep dive. And in this, I want to have a conversation with you on several topics. And let's start with something that's near and dear to both of us, which is kind of to nerd out on technology, on home labbing, and the newest addition to your lab as well, I reckon, the DGX Spark. And in the previous episode, I already had a huge coverage of the bring up and the unboxing and kind of the whole philosophy behind the Spark with Andrew Fu. But you've been playing around with it as well, and like to hear your thoughts. So,
I
like
mean,
first time
this
you had you touched upon the Spark, you
this guy
unboxed it.
here, right? Yeah, he's
Yeah.
great. It's on my desk doing wonderful things for me. Um, I mean, I'm blown away by the thing, right? I mean, we hear, from a metrics perspective, right? People saying, well, it's not the fastest for inference, or it's not not the quickest at that. But it's not built for that. It's built to make AI accessible to home labbers, to open source people, for people to learn and experiment more quickly. And that's what I've been doing. After my experiment with running many GPUs in a cloud by mistake, I'm very cost conscious when it comes to running, you know, GPUs in cloud services. So things like Spark, let me experiment without my fear of accidentally provisioning very expensive infrastructure. Put that aside. And I've been training models. I've been having a lot of fun actually building automations that build data sets. And I mean, you name it, right? I've only got one here. I've got another one on order because I've decided I need more. Um, but it's making it accessible. And I do a lot of demos with internal Red Hatters around AI and showing simple stuff like VLLM for inference. But also, it gives me the ability to segue out and say, right, well, this is what it looks like from a code perspective. Here's some application code that is using AI, and it's all within a single contained little box. I mean, they're small things, but you see the penny drop moment on people when they start to realize that it's not huge amounts of cloud infrastructure. Because when you say AI, people think huge data centers and many GPUs, and the Spark makes it real, and you can touch it, you can see it, and it does a surprising amount for such a small box. And that's where people start to get interested. I mean, all my developer friends, I was speaking to one this morning, and he started a week ago going, I'm not sure about this. Why would I need one of these? He texted me this morning saying, I've bought two. Um, because he's been running some of the smaller code models on on a VM in a cloud, and he got his bill through, and he was like, actually, this is quite expensive. Um, to the point where now he's actually right now, actually, I want to do stuff. It's my code. I'm going to run it locally. So he's bought two Sparks so that he can run a nice big code model and connect it to Cursor and continue writing code and using Code Assist locally. Because of the stuff he works on, he doesn't want to share some of that out to cloud services. So I think there's going to be a growing use case around people just wanting to run it locally, and maybe it's not the fastest for inference, but then moving on from that to saying, well, actually, I do have a data set I want to tune for my code base. This is my repo. This is the stuff I'm working on. And I think we're going to see more of that. We're going to see more people taking the recipes that come with the Spark and tuning it for very specific use cases. So we're going to end up with these smaller models that are just really good at particular tasks. And that's going to drive on to, more agentic flows where you're only using a 9B model to do a particular task. So I'm hoping that's going to drive the community around it, because that's what I bought it for, and that's why I'm playing with it.
Yeah, and I think there's a couple of things you mentioned which are really interesting, because I had a conversation with someone with a developer last week I met, and he said, "Yeah, well, I could buy a Mac Studio with 256 gigs of unified memory as well that can run bigger models on a single device compared to a single Spark, and it's just $1,000 more expensive." I was like, okay, but it doesn't support CUDA. You can't deploy a NIM. You don't have an AI workbench solution that allows you to run those solutions locally. And I think this is one of the added values of the Spark as part of the DGX ecosystem. And you mentioned ecosystem. There's a ton of solutions already built, software solutions around the hardware device that get you up and running in 20 minutes. Like I deployed a new version of Olama yesterday, actually with the IBM. Oh man, the latest version of your model, the Granite 4 models, and I think it ran in like, I don't know, 15 minutes, complete deployment end to end, and I got N8N running on it as well to as an automation platform, for instance, to do some of the automations I do from a podcasting perspective. So, for instance, after this recording, I want to kind of go through the highlights and use those highlights to write a blog, and it does that for me. So. And what's really cool with the Spark, again, like deploying that in a couple of minutes, instead of when you do that on something that's not part of the ecosystem, is a lot harder. So I agree, like a Mac Studio is an awesome device, and you can do a lot more with it than just AI. But purely looking at the use case and what you want to do in the enterprise, this is kind of your gateway into enterprise AI. And that's one of the things I really love about it.
Yeah, absolutely. I mean, it's that, as you say, that sort of turnkey, the stack is just there. I want to do stuff with AI. I don't want to play around with some of the lower level stuff to get the GPU working, to get the frameworks working, because I've got my vision of what I want to work with, and that's what I want to do. So I think that's one of the big advantages of the Spark. And then, of course, being able to take what you build on the home lab and then push it up to the larger infrastructure and have the stuff just work. So I can take my PyTorch code and I can push out a distributed training job, and it's going to work because I know it. I tested it here locally, and it didn't cost me lots of money with cloud resources, which I'm obviously very aware of. But I want to be able to scale it, especially when I'll home lab stuff here. When I go to my job, I want to say, hey, look, now let's talk about how we run it in production. How do we make it bigger? How do we scale it up? And having that confidence that I've done it on a small scale before I pitch it to some of the other team members is a big part of this. Or I go to a meetup and I talk about what I've built. I know it's going to work here, but I'm probably going to demo it on a Red Hat AI cluster, running in a cloud somewhere where I can show it running at a faster speed. But that consistency is key. And that's the same across all the AI stuff we work on. If you've got a consistent platform, you've got consistent tooling, then you can focus on the job, which is doing interesting things with AI, or pushing forward what you're doing with a training job or an automation or a robotic platform. Um, we want that infrastructure to kind of be consistent and fade away. Sorry, I felt like I was pitching to you there. You know this stuff.
Well, it automatically, and we kind of prepared the show today, but it already triggers some questions I have. Like you mentioned Red Hat a couple of times, and obviously you work at Red Hat, and one of the solutions that you guys have developed is OpenShift AI, also RHEL AI, but yeah, let's focus on OpenShift AI during the conversation as well. I mean, how does, and you already kind of gave the answer, but how does the Spark tie into the whole picture? I mean, the podcast is called the Private AI Lab, so we're obviously sometimes talk about the stuff that happens in cloud, but OpenShift and OpenShift AI on top of that are one of the kind of the leading, I would say, private AI solutions out there. But yeah, how does this kind of how does the Spark fit into the entire ecosystem?
Um, well, it's all around open source, right? I mean, all of the stuff that we're running on the Spark, it's the VLLM, the PyTorch frameworks. It's all open source. Um, and as you grow up to deploy things on a Kubernetes platform, at OpenShift AI, we're still following that open source flow, right? So the PyTorch that's running in my container, that's running in my OpenShift cluster, is it's the same container that's running on my Spark, right? I want it to be the same because I want consistency. The GPU is a different profile, but it's using the same optimizations. VLLM is the same VLLM running down here as it's running up in the OpenShift cluster. So that portability from small single node, I'm getting it working, I'm experimenting, I like what I'm doing. Right now, I'm going to push that up into Git, and I'm going to pull it automatically down through my Git pipeline onto my OpenShift AI cluster. It's just it's I say it's simple, right? There's complexity, but it's a Git flow pipeline that we're used to doing when we're building applications, but now we can do it with AI. So if I tune a small model on my Spark, you know, the same code that I ran on my notebook on my Spark runs on my OpenShift AI cluster. This time I can push the training job distributed to 8 or 16 H200s, and I can get the thing done in an hour instead of over 48 hours on the Spark. But the workflow is the same. My result is still a model that I can push out to VLLM and run on inference server to a larger community, because I don't let everyone access to my Spark and run stuff. That's my toy. But that workflow is the same, and that's important because I can scale it. I can, I've got a great guy on my team, James, who does all my OpenShift AI, OpenShift infrastructure stuff for me. He connects the storage and does all of this stuff, because I don't do that
You have an
anymore.
infrastructure guy? That's awesome.
It's fabulous. I love working with James, and he does a lot of the AI stuff as well. But I can say to him, "Hey, I need an OpenShift AI cluster because I'm going to do this," and then he just sends me back a bunch of credentials or tells me says what repo are you pulling from, and he does that for me. So I just go into the notebook, and it's not running on my Spark anymore. It's now running on an OpenShift AI cluster somewhere in a cloud or in one of our data centers, and the workflow is the same. I can step through it. I can debug it. When I'm ready to push that out to distributed training, I can just push it down to Kubeflow, and it's going to run the jobs. But my code is the same. The debug output's the same. Hopefully the crashing isn't the same, but that workflow is what drives the innovation. I've not had to go, oh, right, first I need to connect an S3 bucket or do something with infrastructure. I can focus on tuning the model or creating an automation using an LLM, or you know spinning up the RAG database and building a better encoder, whatever those workflows are. You've got small scale up to full scale without having to adjust the code, and that to me is what it's all about.
Yeah, and I think that totally makes sense. Now, you mentioned OpenShift a couple of times already, OpenShift AI. You mentioned Kubeflow, pipeline. So let's shift gears a little bit and focus on the OpenShift AI side of things, because I've been playing around with OpenShift AI a couple of times or a while already. We are running our dog demo on OpenShift AI, but to those who kind of don't know what OpenShift AI is, could you kind of explain what it is and also how it is different compared to other solutions?
Yeah, sure. I mean, OpenShift AI is part of the Red Hat AI portfolio. So we've got three parts of that, which is RHEL AI, which is Red Hat Linux AI. We've got Red Hat Inference Server, which is focused purely on inference. And then you've got OpenShift AI, which is the OpenShift, the Kubernetes-based platform for running these workloads at scale. At massive scale. And that's a full suite. So we're taking obviously Red Hat, so everything is open source. So we're taking those upstream projects. I mentioned Kubeflow, Jupyter notebooks, all of those capabilities. We're pulling those into effectively as fully supported product to deliver everything from an ML ops capability and a data science capability through to the ability to deploy models through models as a service, VLLM, to do that infrastructure side of things. So it's very much around taking all of the projects that are moving so quickly. I mean, VLLM is a great one, but it's moving so quickly, and making that consistent so you can deploy it as an enterprise and you've got all the pieces wired together. And as a data scientist, I can log in and I can get a Jupyter notebook and I can start writing Python code. And I've got consistent versions of Python and I've got everything there. If I'm focused on delivering infrastructure and I just want to deploy the models that have been built by the teams or I've pulled down from Hugging Face, I can do the same thing. I can pull down a model, it can sit in the model catalog. It's local, so if I want to make everything offline, I can do it all on a dark site or in a fully air-gapped mode. And I can deploy that model across all of my nodes with VLLM consistently. One of the most exciting projects actually is LLMD, which isn't part of Red Hat AI yet, but that's around effectively tying together that inference front end and being able to deliver multiple models on multiple different GPUs if you want, but provide caching for KV cache, for preload cache, and really accelerate that inference part of the equation. So when you think about AI, mostly we think about either data scientists building a model, and we've been able to do that at scale for a long time with Kubeflow and pipelines. But inference was always stateless. It was run inference servers, but LLMs aren't stateless. You've got conversations, you've got interactions. So having that caching, having that ability to run often multiple models and route to the appropriate model to provide an appropriate response is a big part of that scale. And that's what we're building into sort of OpenShift AI and Red Hat AI. The mentality around taking these projects that run really well on their own, in a container or on a Spark, and saying, how do you run that at data center scale? How do I do 24, 48, 128 nodes of GPU? How do I support a 408 billion parameter model spread across 4 GPUs and a 9B or a 7B that's just answering questions about how I book holiday on Workday, for example? How do I do all that on a platform? And that's very much what we're pulling together with OpenShift AI, that data science to full scale production inference. It's a lot of
So
fun. Lots of moving parts.
yeah, and it's yeah. Again, I worked a lot with it in the last couple of months. And one thing that really stands out, obviously, is that there's a tight integration to NVIDIA solutions. So, could you kind of give an idea on how that collaboration between Red Hat and NVIDIA looks like today in the offerings that you guys have?
Yeah, sure. I mean, we've been working with NVIDIA for many, many years. Roll back to, the early sort of rail days. But today it's once again, it's moving so quickly. So the ability to take and fully support the NVIDIA GPUs, be able to deploy things like NIM from the NVIDIA catalog straight onto the OpenShift platform. We've had to work very closely with them to make sure that's a seamless operation and nice and easy. Um, and then you've got other stuff on the back end around things like supporting things like Bluefield from a networking perspective as well to accelerate those networking aspects. So a lot of the work we do with them is around optimizing the infrastructure components, obviously optimizing for GPUs and support across the OpenShift AI platform. Um, so we talk to them a lot. Um, it's working really well. Obviously we like choice, and if you're not using NVIDIA GPUs, we fully support those with VLLM and on across the OpenShift AI platform. So if you're using deployment in Google and you're using Google TPUs, that works as well. So those workflows don't change. Obviously, if your applications are built around CUDA, then there's more there. But from that partnership perspective, NVIDIA are obviously a very strong partner of ours, and we're just going from strength to strength. It seems like this, the velocity is just accelerating. And I mean, you've been using OpenShift AI and you've done a lot with NVIDIA for a long time, right? I mean,
Yeah.
is it slowing down at all, or are we just getting? I feel like we're getting started.
Well, it kind of depends on your vantage point, right? So when I look at like, I always like to compare the build of a private cloud for what kind of like doesn't really matter for what kind of use case. I like to compare it to what we did 10 years ago. If a customer would kind of call us and we would engage with them to design, deploy, and kind of manage or let them migrate workloads on top of a private cloud platform. Sometimes that, I don't know, one of the engagements I worked on, I think we spent like 2 years getting the customer from A to Z completely on top of their new private cloud platform. And especially everything we did around data science and AI, traditional machine learning, was a lot of manual configuration. Sure, some things could be automated, but the stack back then was not as mature as it is now. Like this, I love the simplicity. So there's and you can't really see it, but there's a cluster of 4 Kubernetes nodes running on a Jetson behind me, and I spend like weeks and weeks getting kind of an opinionated stack or curated stack to myself in which stuff works. I could run a CI/CD pipeline in Argo and now kind of deploy an application, and it works. But what I really like is to deploy something, and within, let's say, an hour, you have a full cluster running with everything you need to get started. It's kind of the same unboxing experience as I had with Spark, but now full-blown private cloud. And I think this is where OpenShift and OpenShift AI kind of stand out to me personally. I mean, I've been playing around with it a lot. It runs fully in my lab as well. So there's a beefy machine with a GPU behind the camera. With the entire stack running, and I think I had it all up and running in 2 hours, 2.5 hours. I think this shows versatility. So if a customer calls us now, I need to build a private cloud. Honestly, the design phase is a lot shorter because, especially compared to a couple of years ago, the deploy phase is a ton shorter. I mean, the most costly phase in or timely phase in such a project is racking, stacking, and waiting first of all that hardware is available, and then racking and stacking it, and making sure that the network team has everything up and running, so we can deploy the private cloud on top of that. And I think this is the probably the best example of what you like you mentioned, because everything NVIDIA ties into that as well. I have the OpenShift AI cluster ready in a couple hours. It's not just OpenShift as a Kubernetes platform; it's the entire workload platform on top of that as well. And I think this is definitely something that shows how the development and the innovation kind of is going between a company like Red Hat and NVIDIA, because we want to offer the public cloud experience to a private cloud as well.
Yeah, yeah, exactly. I mean, it's reassuring to hear you say that because we put a lot of work into that. So yeah, um, and I think I mean, we talk a lot about AI factories now, and that is that turnkey, right? It's like, okay, I need this architecture, this private cloud with the AI capability that sits alongside other workloads, and we're maybe 6 to 8 months ago, it was more people being very specific about these pieces, right? But now we're like, well, we know we need VLLM, we know we need notebooks, we know we need the GitOps capability, we know we need Grafana dashboards. But now we care about time to first token, and we care about the streaming speed of our LLMs. So there's other metrics we care about, but that ability to run it, private in cloud or whatever, that ops piece has been massively accelerated. And customers want to get to the point of, well, I know what I want to start experimenting with my AI. I want to be able to take this model. I want to take these 5 models, and I want to try the same thing out against all of them. So the stack stands up quickly because we're getting better at understanding what that software stack looks like. And we're moving on to, like we talked about at the start with the Spark, I turn it on and I'm doing things with AI. I'm not trying to get AI working. And that's where we've with the point we've got to. We've got that infrastructure solved. We've got the GPUs. We've got that. It's not a fragile stack anymore. Now we can move on to be doing things with AI that make a difference, and that's exciting. That's the new bit. That's the shiny bit, right? Of course, every other day we're getting a new model to try and experiment with, which is another challenge. I love the fact that I wake up on a Monday morning and there's a new super duper model that I can experiment with, and I can, and they're all
Yeah.
open source, right? So I can download it from Hugging Face, and I can either run it on my Spark, or if it's really big, I can run it on my OpenShift AI cluster, and I can be experimenting with it almost before my coffee's got cold in the morning. And look back a year, we could never do that. We were like, well, how am I going to do this? Which components
No.
do I need? Oh, I've got the wrong version of PyTorch, or this. But now I'm playing with a foundation model that is part of a research paper, and I'm running my tests and my evaluation against it, within a couple of hours. And I can go, right, well, this is better than what I've currently got. I'm going to take away this model. I'm going to put this one in instead, and I'm going to run my workflows. And I do it a lot in labbing and obviously demonstrations, but that makes a difference to customers. If a model is more accurate and all you've got to do is flick a switch and turn half the traffic to this model and half the traffic to that model, and suddenly your service becomes better. It's almost going back to that, the ability to do that with cloud native. You bring a new feature, you do a traffic redirect. We can do that with AI models. That's, to me, that's really exciting, and that's all driven through open source and
So
sharing and collaborating.
yeah, and there's a couple of things that about what you just mentioned that's really interesting. First of all, you mentioned open source, and I think one of the biggest misconceptions is that a company like Red Hat sells platforms that are not open source. But I think that's misconception number one, because everything is, like you mentioned earlier in the episode, is open source. It's you're using the upstream version of the platform, but add your magic to it. Let's call it like that as well. Um, I think, and I am really strongly opinionated by it. Um, by kind of the following thing. I mean, there's really a big place for open source, and there's a massive place for the CNCF as well. I think there are tons of companies who are really successful by fully implementing a open source platform based on the CNCF landscape. They built their own opinionated stack, and there's definitely a place for that. But in the era of AI, where everything needs to innovate as fast as possible, um, you don't want to focus on first creating an open opinionated stack and then deploying it and then hoping that everything kind of ties together and is supported and the whole thing. Like, and this is kind of one of the things I definitely also wanted to talk to you about as well. Like, what if customers are now kind of debating on or investigating what kind of stack to build? What's your take on the ideal stack for a production AI workload?
I think, well, I like to think the Red Hat one, of course, which is, I mean, maybe 2 years ago, we were debating whether Kubernetes was the right place for AI workloads, right? And I think that debate has largely resolved itself now. We've done some changes to Kubernetes. We're we're upstream. Well, we've got a whole bunch of other optimizations around Kubernetes, around workload placement, GPU sharing, and stuff coming in from the community. So I think Kubernetes as that distributed platform is kind of the foundation for this. But then when you look at you know serving frameworks, VLLM is the open source project for serving generative models, right? AI models, um, and it's just got this groundswell behind it. So VLLM is the inference server. Obviously, PyTorch is a core framework. The tuning and the data science piece, I don't think we have a full prescribed stack there. The the techniques that are coming out of our AI innovation lab, and obviously the likes of Meta and NVIDIA, they're that development world is moving still very, very quickly, and new approaches around how you optimize models and things are happening every week. So there isn't a prescribed stack for building LLMs, but for that production running, VLLM is the inference server. The training platform, Kubeflow, MLflow, that's where we're seeing that activity, and then things like Feast for feature storing and stuff like that. So we have all the pieces there, and I don't have much debate around which one over another. When I talk to people at KubeCon recently, they there isn't a kind of like, no, this is the wrong framework. There seems to be the community has come behind a lot of these frameworks and said, well, this is what the stack looks like, right? Infrastructure, yeah, we're going to use Kubernetes. VLLM, we're going to use that for inference. Obviously PyTorch is a core framework for doing the model building. I'm not seeing much back and forth there. That time seems to have passed, and I think a lot of that is the maturity around things like NVIDIA, the Spark. Those stacks have got to the point where we just deploy them and run them the same as we go. Well, we're just going to run everything as a container. We don't debate that anymore. We just go, well, it's going to be a container. That's how we package it. Um, so that's not confusing to me, or I think to anyone building the stack. I think where it gets exciting is where you say, well, I'm going to build it myself. I'm going to take all of the open source components and pull it together. Um, and I've done that, right? I did that with Kubernetes, and I've done it with AI to a certain extent. You and I have had many conversations on that in the past. And even you talked about the Jensen Nano earlier, right? I've got a few of those around. That stack was hard to get working because mostly PyTorch versions and Python. I mean, we've had Python for so long, and yet Python version hell is still a thing. Um, we learn from all of that, and you can do it, but that's not where the value is. The value is building something on top of the AI. You know, unless you want to contribute to VLLM or you want to contribute to some of the underlying parts of the stack, take something that works and then innovate on top. And that's, I don't know if I've actually answered the question. I've talked about lots of projects there, but
No, I think what you said really makes sense. It's I think like one thing I didn't really think about, like Kubernetes is, we can mention that Kubernetes is the de facto standard when it comes to container orchestration, right? So or platform orchestration, if you will. And looking at open source solutions or open source frameworks or projects to actually build models or to I mean, we see a lot of Kubeflow, we see a lot of MLflow, and I think this is definitely one of the things that we'll be seeing in the upcoming year as well, or years even, is that some of these projects will become the mainstream project when it comes to building such a model. Or I mean, you mentioned PyTorch. One of the things that's common between all of them is that Python seems to be the de facto standard when it comes to like the de facto standard language to run data science workloads,
yeah,
and more and more. So it's yeah, coming back to like what's the ideal stack. Um, Maybe the answer is that we'll be seeing, or the fact like the ideal stack is shaping more and more towards what we think is the ideal stack.
yeah. And I think there's the flip side is that obviously Python is just there, right? It's not the most
Yeah.
efficient language to run a workload, but because the frameworks have been around, there's so many frameworks, the support is there, especially from traditional data science. The uplift to change that, it's not really in anyone's kind of best interest, to be perfectly honest. I think maturity around other languages, so Java, my background is Java, so I default to Java, right? Having, you know, Java, also Java frameworks that can integrate or interface more seamlessly with AI applications is where we're going to see, more interactions, right? So today it's really easy to just go into some Python code, import LangChain, and do some stuff. But if I'm an enterprise and I've got 30 years of Java code, I want to take advantage of AI. I can't rewrite it all in Python, right? So how do I modernize what I need to modernize to take advantage of generative AI to talk to my LLMs? So those points, those extensions to language frameworks, those how do I pass security tokens backwards and forwards if I'm trying to do an agentic workflow and my application is written in COBOL? Can't really do that today. Let's talk about how we're going to modernize the application. But it's the same with other languages, C++, Java, Go. Those challenges around authenticating, passing credentials around, interfacing with the LLMs running at inference, and then interpreting the responses. That's not terribly mature. And I think for enterprises to really accelerate with a lot of that stuff, especially in the private AI area where you don't want to share your code base, you've got your own APIs that you want to connect to agentic frameworks, and everything is running locally. That maturity has to happen in order for us to really connect those workflows and start to make a real difference with things. It's very easy to build a RAG demo today. It's very easy to use N8N to do some nice workflows to show stuff. But if I've got 20-year-old Java code that I have to simplify, right? I need to make it easier for my people to be able to use the application, and I'd like to use AI. There's a gap there, and I think that's that's an opportunity for open source to kind of accelerate, and we are seeing it, but not as rapidly as around more Python, please.
Let's talk about that gap, because what would be your recommendation for companies trying to move from the POC hell to production? I mean, like there's, I think I read a research paper earlier this year stating that 79% of all proof of concepts never end in production. So 21% of the POCs end up in production. And like, first of all, what's your take on that? And second, what will be your recommendation for customers to increase the probability of a POC actually happening to go to production?
Yeah, I mean, I think that metric is probably accurate, right? I would also caveat that with, well, how many, you know, development projects or infrastructure POCs don't quite make it to production? So that number's probably not just AI, but equally there's a big gap there, right? 70% failure rate. But I think a lot of that is from initially, as we know with all POCs, if you don't have well-defined criteria, you know, it's hard to have success. And when we're talking about generative AI, you know, I get asked the question like, what can I use AI for? You know, what's the use case? How do I, you know, so sitting down and having someone understand the problem domain and really focus on what they're trying to achieve with an AI POC, I think that's the first misstep that often happens in a POC. It's someone's so desperate to run out and do something with AI, they don't think, should I be using, is this use case appropriate for generative AI? Maybe it's better to use predictive, or maybe it's better to use a combination, or maybe, you know, some nice Java code would do the job just as well. So I think sometimes we get, you know, so excited with the technology, we want to use the technology for everything. So sit back, all right, what are we trying to achieve? Is a large language model the right use case here? Should we be using an LLM for this? So that planning step is critical. And I'm not talking about building data sets to train a model, but just what does that workflow look like? What are we trying to achieve? You know, am I trying to build yet another chatbot, or am I trying to do something with a system that is going to be differential to my business? You know, if I'm just building a chatbot, what does success look like? So setting that criteria around an AI POC is so important. And then how do I move that POC if it's successful? How do I take that into production? You know, how do I scale my inference surface? How do I scale GPUs? How do I make sure that my GPUs are used most efficiently? And how do I monitor it? How do I secure it? How do I, you know, how do I make sure my auditors are happy? So when someone says, hey, Johan, I love what you've done with AI, but how did it get to that decision? And you don't have to go, computer said so, right? So all of those pieces are so important to success, and they're not necessarily thought about up front because you're so busy trying to do something with AI. I mean, they're quite boring, right? A lot of them are boring platform pieces, but critical to a production platform. You know, the audit stuff, logging every prompt you can and then analyzing all of those prompts, using guardrails to make sure your model doesn't go off and do something you don't want it to do. They're not generally part of the POC, but if you're processing 10,000 prompts an hour, that log is going to move up, going to become a management factor. And what do you do with that log data? You know, actually what you should do with it is analyze it and use it to improve the prompts and responses to the models. But that feedback loop isn't part of a POC generally. So all of those complexities about running an AI platform at scale, you know, they're the things that trip people up. You know, because you used all of your budget on the GPUs or on the POC, and actually there's a big gap between POC and a production with thousands of users on it. That sounds really depressing. It's not as hard as it sounds, but
Well,
there's more to think about, right?
so and it totally resonates. But like looking at, so let's end it up less depressing. So what's when you look at all of the AI use cases you've seen being built in production, what's kind of your favorite one done right?
I I think my favorite ones are always the ones that impacts. I like AI for good, right? I mean, I think AI should be, making people's lives easier, safer, happier. Um, and we had a hackathon that we did for with a partner with US Veteran Affairs, and the hackathon was around let's do something with AI. But what they built was a platform that did a whole bunch of sentiment analysis and analyzing interactions to highlight where a veteran might be having a problem and they should be getting further assistance from a specialist of some kind. And those projects, and there's a few others I've spoken to people about that are similar, right? Taking conversations, taking context around interactions or data points around how long someone's spending using particular services, and then using the AI models to flag a potential health issue, safety issue, you know, if someone just needs to have a conversation with another person to make them feel better, those kind of workflows that have a human impact, you know, because, at the end of the day, we want AI to make our lives better. Sometimes it's just asking a chatbot, how do I book holiday? But having a system reach out to you and say, hey, Robbie, why don't you call Dave because I think he's having a hard time? Those are the projects that I'm more passionate about. And like, the technology is the same, but it's that use case that drives something special. And I love nerding out about
Yeah.
technology, but if I can have a system reach out to me and say, hey, something's not right with your friend, please give them a call. I'm all about that. I want that for everybody.
Awesome. Well, I think a great way to end experiment number 2 and segue into experiment number 3. Because in the final experiment of the show, I like to kind of recap of what did we learn today. Let's start with that. So you first. What's kind of the number one thing you want the audience to think about or to take this away from?
Yeah, you scared me for a second there. I was suffering catastrophic loss. I was like, I can't remember a thing. Um, but I think the thing to take away is, we have reached a maturity curve with AI to the point where it's very accessible. Where it's accessible from private labs with things like the DGX Spark. Obviously, we have cloud services to access GPUs in the cloud, but the software has become more accessible. It's all open source. You can download pieces, you can experiment, you can play, but the AI models themselves are the same. Most of the innovations around AI, is being pushed in open source. You can download an IBM Granite model. You can download a Hugging Face from Hugging Face. You can download a Llama model, and you can experiment. So there's no barrier to entry there. It's just thinking about it and playing around with it. The software stack has matured to the point where we can get something running while we're still drinking our coffee in the mornings. So that initial accessibility is there, and then obviously the ability to scale. We know how to do that now, and that's my key thing. And of course, I'm desperate to talk more about the Q9 dog, but we can do that another time.
Ooh,
Robotics
and
and AI.
that's yeah, that's definitely a segue into kind of the second question I have before I let you go. I want to be conscious of time because I have nothing to add to what you just mentioned as a wrap up of the episode. Question number 2 is I will invite you over a second time as well. And potentially that would be 1 year from now. So if I would invite you over 1 year from now, can you make a prediction? What has changed in the world of AI?
I thought we'd get to the end of the show without talking about agentic AI, but here we are. Um, I think I mean, we're all talking about agentic and the fact that AI agents can go off and do things. And we're at the point now where we like to talk about it, but I feel there's a lot of hype around it. Because when you talk to someone about agentic and what it means, they think it means going off and doing something, but it's more about agency, and giving a system permission to go out and use your credit card and not have it run up a massive cloud bill because it's done something wrong and you've got the consequences of it. So that agency part of agentic, I think, is where we're going to see maturity and the trust in those systems. I mean, I'm very excited about the fact that I'm going to be able to say, hey, book me a scuba holiday in the Caribbean. I want to go for 2 weeks, and the system go off and it book my holiday, tell my boss, book my flights, and do all that for me. I'd be very excited if we're there in a year. But having those levels of systems, having just something that can book a holiday for me, I'd be happy about. So that those agentic interactions, I think, are where we're going to see most of the stuff next year. Not necessarily just from an AI perspective, but from making systems accessible to AI. And that's a big part of it, right? Is changing APIs, changing access control systems to make them more AI accessible. So I think that's probably the same as everyone else, right? It's going to be the year of agentic.
Well, it's a lot different than the year of VDI, I guess. No,
We'll
dude,
get
I'm looking forward to that. I'd love when I can just, send a little prompt and holidays booked. Kids have been like properly, like everything has been packed. Kids are ready to go on holiday, and like everything's
so
working. No, I'm
you're about a
looking forward
robot
to
that can
that.
pack your suitcase. I like that. A robot that can pack
Dude,
my
that
suitcase.
would be amazing to have a humanoid packing the bags as well. No, really cool. I really enjoyed this episode. So, Robbie, final question before I let you go. If people want to know more about you and the things that you do, where should they go to? Where should they follow you?
Yeah, I mean, absolutely. I mean, follow me on Twitter, Robbie J on Twitter. Um, you could also drop me an email and I'll get an AI agent to respond to it, which is robbiej@redhat.com. Spam me too much and I, won't respond. Um, those are probably the best places to interact with me. I'm probably more active on, say, X now. I still call it Twitter. I'm old school. But that's
I do
where
too.
you can. Awesome. Thank you, Johan.
Awesome, man. Yeah, awesome, man. Thanks so much. Thanks for tuning in to the Private AI Lab. Don't forget to subscribe on Spotify, Apple Podcasts, or YouTube, or visit johan.ml for more insights and experiments. Experiment complete. Until the next one, stay curious.